Alright, hey guys, thanks for joining me on another video. Good morning, or maybe good afternoon or good evening. I'm hoping you're compound interest is how all your banks work, all your savings accounts, your credit cards. So it's something that you probably do want to know about. And make sure you have a calculator today. We will be doing a lot of calculating and calculations. So take a look at this warm-up. The long-term data for the stock market points to a 7% annual return on investment. For the period from 1950 to 2009, if you adjust the S&P 500 for inflation and account for dividends, I don't know what that means, the average annual return comes out to almost exactly 7%. It just means if you invested in the stock market in the S&P 500, you would have made about 7% a year from 1950 to 2009. So the S&P 500, by the way, that's a list of some of the top companies in the US stock market. So if you invested in S&P 500, you will be investing split up evenly between companies like Microsoft, Apple, Amazon, Facebook, I don't know, Visa, Verizon, Home Depot, stuff like that. So among the top 500 companies in the US, so without a calculator, I want you guys to guess. So we will be needing a calculator today, not for this first part yet. I want you to guess how much money would you have if you invested $1,000 into the stock market after 25 years, assuming you get 7% each year. So just for example, we know after 1 year, right, we'd multiply by 1.07. We'd make 7% of 1,000. We'd make $70. So after 1 year, we would have exactly $1,070. So think about how much money you would have after 25 years. And then how about after 50 years, if you invested 50 years ago? And then try to make a guess about if you just increased the percentage by a tiny bit, by 2 percentage points from 7% to 9%, how much would your return be? All right. And again, these are just guesses. This is usually pretty interesting when I do this in class. I get all sorts of different answers, right, ranging from like $2,000 to, I don't know, many thousands of dollars. So it's a good way to test your intuition about whether you really understand how compounding works, or in other words, exponential growth really, because this is really just exponential growth. And let's see. So after 1 year, you'd have 1,070, right? The next year, we'd multiply that by 1.07. So that $70 that we got the first year, right, that's also making money. That's also being multiplied by the 7%. And that's what we mean by compounding. So this is an example of compound interest because your interest is making interest. And the longer you have it in, the more interest you will accrue, and that accrued interest will keep making interest. So you keep taking 7% of a larger and larger amount. So to figure out how much we would have after 25 years, that would be our initial investment of $1,000 times 1 plus our rate, right? This is exponential growth, so 1 plus 0.07 to the 25th power. All right, so doing that in your calculator, you would get approximately, with money, always go to the nearest cent, $5,427. So that's actually really good, and that's actually like you more than quintupled, you more than multiplied your initial investment by 5 times. It did take 25 years, but that's pretty good. That's pretty good. Right? How about after 50 years? So twice as long of an investment. Right? Some people might think, all right, it's going to be around double that, but it's not linear growth, right? It's exponential. You know our exponential graphs. Boom, they go like that. So let's see how much after 50 years. It's 1,000 times 1 plus 0.07 to the 50th power. This is actually around 29,457 0.03. So this is like, that's almost like times 5 of that amount. Again, more than times 5 actually. So, wow, that's pretty good. What if it were 9%? Well, we would do 1 plus 0.09 to the 25th, right? And one, copy and paste this for 50 years. Just change the exponent to 50. And let's see what this is equal to. So all we're doing is increasing by 2 percentage points, right, from 7% to 9. And this is actually approximately $8,623.08. Right, compare that to the 5,000 something we had before. That's quite a big difference, right? And after 50 years, well, with just $1,000, we would have $74,000, $357.52. And that's like 2.5 times that amount, almost. Is it? Yeah. So, pretty cool. All right. This next part, this is actually review of percent manipulations. So actually, if you feel like you really understood the percent manipulation stuff, you can skip this part. Right, and hold on while I'm going to tell my kids to be a little quieter. Can you guys? Thank you. All right. So, in this next problem, we deposit $100 into a bank account with an annual interest rate, APR, of 6%, and that's compounded annually. So, this vocab, we're going to talk more about that in a couple minutes. But APR, that's the amount of interest you get in a year if you are compounding annually. All right, so compounding annually just means we're applying the interest once a year. Right, and by the way, this word compounding or compound, this only applies to things with banking, like the stock market or a credit card or a savings account or any kind of bank account. You'll see this word compounding, and it's really unique, and that's only has to do with banking. So if you're doing populations or other kinds of exponential growth, we're not going to be talking about compounding there, just with banking. So write an equation that models the amount A of y, the investment, is worth y years after the principal has been invested. So the principal is the amount that you're putting in, your initial investment. Right, we're putting in $100 to start, and our interest rate is 6%, so that's 1 plus 0.06. That's our yearly rate, so this is just to the y power. Right, and this would be the amount we have after y number of years. So after 5 years, this would be A of 5. That would equal our $100 initial investment times 1 plus 0.06 or 1.06 to the 5th power. Right, doing that, we're going to get $133.82. Letter C asks us to write an equation that models the amount A of m now, so we're using a different time. Instead of years, we're using months now, that the investment is worth m months after the principal has been invested. So, A of m is equal to, so if we're using after m months, let's find the monthly rate. So the monthly rate is going to be our yearly rate, 1 plus 0.06, right, or our yearly growth factor, raised to the 1/12th power. So this entire piece here, this here is using our monthly rate, and what I highlighted is our monthly growth factor. So a lot of people aren't comfortable with this, so if you would like, you can type that into your calculator and take the 12th root of 1.06. If you do that, you get approximately, if you're going to use this decimal, write as many digits as you can to keep it accurate, but that's around 1.00487, 67 55 dot 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 dot, right? And if this is our monthly rate and we want it in terms of months, well, we can just raise this to the m power. So this thing here and this thing, well, these are equivalent, right? 1.06 to the 112th power is equal to this decimal. So if I want, I can also just take this, that's our monthly rate also, right, raised to the m power. Right? This is our exact monthly rate. This decimal here is just an approximation. So we know from our power to a power rule, when we have a power raised to another power, we can multiply the powers together. And so another way to write this is just to the m over 12th power. Right? These are both acceptable for a of them. So how much is the investment worth after 5 years? Well, now this was in terms of months. So 5 years is equal to 60 months. So if I'm using the monthly rate, I want to plug in a 60. And that's going to be our initial investment of 100 times our monthly rate, which was, if you're using the decimal, that's 1.00486755 dot 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 something, right? Raise that to the 60th power. All right, so go ahead and type that into your calculator. All right, and hopefully you got the same answer, $133.82. Or if you want to use the exact equation, I would actually say this is the better equation. That would be 1 plus 0.06 to the 60 months divided by 12. Wasn't 60 over 12 5? So of course that's the same exact thing as that, of course. And that's also going to give us the same answer again. And letter E, now let's write the amount in terms of years using the monthly growth rate. So A of y is equal to, I want to use the monthly growth rate, which is this value, or 1.06 to the 112th power. So I'll use the exact version. This is our monthly growth rate, 1.06 to the 112th power. And because we're talking about years now, right, this is in a month. So in a year, I need to do this 12 times, right? And so that's to the 12y power. Or again, if you would like, you can use the decimal version, 1.00486755 dot dot dot. Again, that's our monthly growth rate. I think I've been calling it a growth rate. It's a growth factor, or monthly growth factor, right? And again, that will be to the 12th power, right? Because we applied this 12 times in a year, and so by the year it's 12y, right? So the main part people mess up on this, again, is the exponent. And again, the reason that is because they try to convert from months to years. And people will say, 1 year equals 12 months. So if I'm trying to get this m in terms of years, right? Well, they think 1y equals 12m. But that is not true. It is 12y equals 1m. And because, again, you can't just change units into a variable, right? If we think about it, if we plug in 1 year, if y is 1, right, then m is equal to 12. And that makes sense because there's 12 months in 1 year. Right? If y equals 1, then m equals 12. That should make sense. So you can replace the m with 12y, or if you just think about this as our monthly growth factor, you know you need to apply it 12 times each year, so to the 12y power. So again, if I plug in a 5 into either equation, I will get the same answer, 133.82. Right, because we're not really changing our interest rate, right? We're just writing different variations of the same formula, essentially. All right. So that was compounded annually. That means we applied the interest once a year. What if we compounded monthly with the same interest rate, but it was compounded monthly? All right. So like I was saying before, this is something that is only done in banking. This word compounding, this only applies in banking. So later on when we do other kinds of problems, we're not going to be doing what we're doing here. But with money, what they do when they compound monthly is they take your percentage rate. They take your 6% percentage rate, and then they divide it by 12. All right. Why do they do this? Well, I honestly believe it is to confuse consumers and just make it more difficult to understand your finances and what's really going on. But I'll save that for another time. But anyway, 6% divided by 12 is 0.06 divided by 12, which is 0.005. So they take your interest rate and they divide by 12, you get 0.005, or if you change that to a percentage, that's 0.5%. So they take your 6% interest rate, and instead of applying 6% interest at the end of each year, what they're going to do is they're going to apply 0.5% interest at the end of each month. So 0.5% interest is applied 12 times a year. In other words, each month, right? We're compounding monthly, rather than 6% once. All right, so we started with this APR. That's what we get, 6% in a year if it was compounded just once a year. But compounding monthly, what we do is we split up that 6% into 0.5%. We divide by 12, and then we apply that 12 times. All right, that's what it means to compound monthly. And you can compound by any length of time. You can compound daily, you can compound twice a year or 3 times a year. It's going to be the same kind of setup, and we'll see that down here in a second. But going back to this problem, if you want the amount of money after some time, let's call t in years, it's going to be $100 we invested times 1 plus. So again, it's going to be 0.5%. It's not always a nice number, so I want you to leave this as a fraction most often. All right, it's going to be 1 plus 0.06 divided by 12. That's 6% divided by 12. Raised to, though, well, this number in here, this is now our effective monthly growth rate, right? So we're going to be doing this 12 times each year, so to the 12t power. So let's say we wanted to find, I didn't specify, but what's the investment worth after 5 years now if we're compounding monthly? So A of 5 would be 100 times 1 plus 0.06 over 12 to the 12th power. This entire thing, this is like the actual amount of interest we're getting each year, right? Because we're applying the 0.5%, the 0.06 divided by 12, right? Again, that was the 0.5% interest in a month. We do that 12 times in a year. So this entire section, that represents the amount we're getting in a year, the actual amount we're getting in a year. And we're going to raise that to the 12 times 5. Sorry, going to just do times 5 to the exponent because we're doing 5 years. And once we do that, this is equal to, all right, make sure you can type this into your calculator, try it, and hopefully you are getting $134.89. All right, so this compounding monthly is actually a good thing because if we compare it to when we compounded just once a year, it's actually more money. It's about $1.07 more. So the more often you compound, the better it is actually. And that's because after 1 month, you're already getting some tiny bit of interest, right? And that interest, that's going to make more interest. So your interest is making interest sooner. So the more often you compound, the more money you get. And so if we compound each week or each day, we'd get even more money than this. Because you're going to be getting interest earlier on. And overall, we're getting the same, have the same APR, but it's broken down into finer and finer increments. So your interest overall generates more interest the earlier on you get it. And hopefully that makes sense. All right. So that was what we get when we compounded monthly. And so let's do it twice a year, 4 times a year. Let's compound monthly and daily. So this first column here is how often we are compounding. How often the interest is compounded. In other words, it's how often the interest is applied. I'll just put in parentheses applied. All right, we have this thing called APR. That is what I'm giving you here. We have an annual interest rate, an APR of 6%. Right? This 6%, that is what you would get if you're compounding annually. Right? APR stands for annual percent or percentage rate. This would also oftentimes be called the nominal rate. Right, the APY, this is the actual amount of interest you're getting after you take into account compounding. So this is the actual interest, or a lot of times they'll use this word. This is the effective interest rate. After considering compounding. Frequency. So after taking into account how often you're compounding, this will be your effective or actual, what you're actually getting after a year. Right? And I'll explain more what that means when we do an example. All right, but the APY, that stands for annual percent yield. So yield is kind of like what you actually get compared to this number, which is just what you get if you're compounding annually. And why do they have these two things again? Again, honestly, I believe it's just to confuse consumers and make it harder to understand what's going on. But I don't really know enough to say for sure. But there we go. All right, and so if we're compounding annually, how much will we have after 5 years? We did this earlier up on top. I will just copy and paste it. All right, we did this over here. Copy, paste. So after 5 years, if we're applying interest once a year, we will have that. Right, the APR they gave us was 6%. Right, so the APR, it's going to be 6% for all of them. That doesn't change. But depending on how often we compound, the actual amount of interest we'd get after a year is going to vary. Right, but if you're doing it once per year, you're actually just getting 6% interest a year. All right. We already did the same scenario for monthly, so I'm going to copy and paste that too for the monthly portion. Copy. And I'm going to get rid of this A of 5 part because it's not the same function each time. So there's our calculation. So for monthly, right, like we said, we took 1/12 of the interest. We actually just divided the 6% by 12, and we applied that 12 times over the course of a year. So this here that is what we're going to use to calculate our APY, or our effective interest amount. So if you do that, what this turns out being equal to is approximately 1.061678. So this is our effective growth factor. To get the rate, we have to minus 1, right? And moving the decimal place 2 places over, this is around 6.17%. So you see, if we compound monthly, we're actually making 6.17% rather than 6%. And I should write the amount of money, 134.89. All right, so let's fill in the rest of this table. What if we're compounding twice a year? So I'm going to write out what this means in words again. If we're compounding twice a year, that means we're going to divide the 6% annual percentage rate by 2, right? If you divide 6% by 2, we get 3%, and then we're going to apply, we will then apply this 3% interest rate every 6 months, or twice a year. All right, so I'm going to do the calculation first for after 5 years. So after 5 years, we're going to have our initial investment of $100 times 1 plus 0.06 divided by 2. So in other words, we're applying 3% interest. We'll be doing that twice a year, so raise that to the second power. And we're doing this for 5 years, so we're going to take all of this and raise that to the fifth power. But of course, when you do a power to a power, again, that's multiplication. So we can make this to the 2 times 5 power. And typing that into your calculator, you should be getting 134.39. And again, you can see this is better. Compounding twice a year, we got more money. Because after 6 months, we applied interest once, and now once we applied the interest again, that interest we made after 6 months, that gets more interest, hence we get more money. And you can see it's not quite as much as if we're doing it monthly though. So to calculate the APY, the effective amount, right, this is the actual amount of interest we're getting each year, or the amount we're actually multiplying by each year. So that is 1 plus 0.6 over 2 squared. And that's going to equal 0.0609 something something something, right? Rounding to the nearest tenth or hundredth of a percent. You subtract 1, right? Here I'll do it out nicely one time. 1 plus r is 1.0609, right? That's our growth factor. To find the rate, we're going to subtract 1, and that's going to be about 6.09%. So that is our APY, if we're compounding twice a year. So hopefully that's enough for you guys to fill in the rest of this table. So if you want to pause the video and try it, that would be great. All right. So now if you want to check your answers, let's take a look. If we're compounding quarterly, or 4 times a year, that's going to be 100 times 1 plus 0.06 divided by 4, raised to the 4 times 5 power, right? We're taking our 6%, dividing it into chunks of 4, and applying that interest 4 times a year, or every 3 months. And that's going to be about 134.69. So 30 cents better than twice a year. Again, not quite as good as monthly. And to get the APY, we're going to take this, calculate our quarterly growth factor, right? Subtract 1 from it, change it to a percent, and that's about 6.14%. And lastly, if we're doing it every day, and this is usually how most bank accounts actually calculate interest, then that was going to be, or that is going to be 100 times 1 plus 6.06 divided by 365. Taking our 6% interest, dividing it into 365 chunks. We apply it every day, so to the 365th power. This is in a year, right? And so in 5 years, we multiply that by 5. And I did not calculate this one yet, so hold on, let me type this in real quick. Where is my... This here is $134.98. And whoo, we made 9 more cents than before. It's pretty good. And so with an APR of 6%, we are actually getting, copy and paste this, paste, what is this equal to? 1 plus 0.06 divided by 365, close parentheses, raise this to the 365th power. That is about 1.0618. So that is about 6.18% APY. All right, so again, APR, that's your annual interest rate if you're compounding once a year. APY, this takes into account how often you're compounding. So these words, they show up all the time. You guys might start getting credit cards soon if you don't have them already. But credit cards, very, very dangerous tool. All right, this is from all of those contracts you sign. You will see something like this. And this is a pretty typical APR for a credit card. So let's just look at this first row here. Interest rates and interest charges. So you get 0% intro APR for the first 15 billing cycles. After that, your APR is going to range from 15.99% or 16% to 24.74% based on your credit worthiness. Credit worthiness is how good your credit is, how reliable they think you are as a consumer paying back your bills. So these APRs will vary with the market based on the prime rate. Right, but holy cow, 16% to about 25%. That is a huge percentage on your credit cards. And what they do is they do 0% intro APR for 15 billing cycles for 15 months. So you're going to be buying things thinking, oh, great, no interest. But after 15 months, you're going to be hit with a huge amount of interest each year. So yeah, let's just say your actual APR was 20%. And by the way, of course, they're going to give you the APR, right? Because the APR is less than the APY. The APY is going to be the effective after you take into account how often they compound. And with a credit card, they compound daily, right? You have to really look into the fine print for that. But this is compounded daily. So this 20%, it's actually more than 20%. If you want to figure it out, well, let's figure it out. The actual APY is going to be 1 plus 0.2 divided by 365 raised to the 365th power. And let's see what that's equal to. 20. That's 1.22133 something something something. So it's actually 22.13%. If the APR you're getting on your credit card says 20%, what they're actually charging you effectively a year is 22.13%. And again, like I was saying before, why do they have this? I really think it's just for confusion sake. And so whenever you apply for a credit card, I guarantee you 100% they're going to be showing you APR because APR is a lower amount, right? And you're actually going to be paying back more. But if you look at a savings account, they will be advertising the APY, the effective amount, because that's more. and they'll be like, oh, open up the savings account. They'll give you the actual amount you'll save because that's a bigger number. Whereas when you're applying for a credit card, they will show you the APY, which is a smaller amount. So a lot of tricky business going on here. And these are compounded daily. So we already know how fast interest grows if you are not paying it on time each year or each month. All right, it's gonna really skyrocket out of control. All right, enough with that, but I thought that was pretty interesting. Oh, and by the way, if you look at average savings rate, I'm just gonna Google that real quick. Savings account rate. Hold on. In the U.S. average. All right, let me just show you a quick picture of this. Camera. Bam. So average interest rate for savings account, according to the FDIC, the national average interest rate on savings account currently stands at 0.09%. And look, do you see that APY? Of course they give you APY. The APR is going to be even lower than that. So, yeah, compare that to 16 to 24% on a credit card. So, guys, once again, in the real world, you gotta be careful. You gotta understand how things work. So, there you go. All right, here are some questions. So based on what we did today, hopefully we can answer these questions. So the value of an initial investment of $400 at 3% nominal yearly interest rate. So nominal yearly interest rate, what does that mean? Aha, this was our nominal rate, the APR, if we're compounding annually. All right, so we got a 3% APR compounded quarterly. Compounded quarterly. Quarterly means 4 times a year. 4 times per year. Can be modeled using which of the following equations, where t is the number of years since the investment was made. So if we're compounding quarterly, that means we're compounding 4 times a year, so our exponent should be to the 4t power. We can eliminate choice 2. Right? But if we're compounding quarterly, again, what they do is they take that 3% interest and they divide it by 4. So inside the parentheses, we should have 1 plus 0.3 divided by 4. Right? I don't see that anywhere. So let's actually figure out what 0.3 divided by 4 is. That is 1 plus 0.3 divided by 4 is, I'm going to cheat, 0.0075. And so choice 1 is going to be our answer, right? If we're investing 400 to start with. Bam, and the exponent, like we said, is to the 4t power. So this first one is choice 1. All right, an investment that returns a nominal 4.2% yearly rate, but is compounded quarterly, has an effective yearly rate closest to what percentage? So we know the effective yearly rate, if we're compounding more frequently than once a year, it's going to be more than the APR. Right, so what is that going to be? It's going to be 1 plus 0.042, or yearly rate, divided by 4, raised to the 4th power. And let's see what that's equal to. 1 plus 0.042 divided by 4. Close parentheses, raised to the 4th power. That's going to be approximately 1.04266. So changing this to a percentage, that's going to be 4.266%, or approximately 4.27%. Cool. All right, and last one. If an investment's value can be modeled with that equation, then which of the following describes the investment? So we can see that we're investing $325, and that's going to be our interest rate. Our APR is going to go here, right? That's going to be 2.7%, and it looks like we're compounding it 12 times because we're dividing by 12. So it's going to be 2.7% compounded 12 times a year, or monthly. So that looks like choice 4. And oh yeah, by the way, there is a formula that goes with compounding. I didn't give it to you though. I guess I'll give it to you now. But hopefully from what we've done, this formula I'm about to give you will make perfect sense. Right? The amount you have at the end is going to be P. P is principal. P is the amount you invest. Right? That's going to be your principal or the investment times. So normally it's just times 1 plus R, the rate, right? But with this compounding business, let's say N is how often we compound. So we're going to take our rate and divide by how often we compound. So N is equal to the compounding frequency. Right? When we were compounding every month, N was 12, we were dividing by 12. Quarterly, you divide by 4. Twice a year, divide by 2. Daily, that would be 365. Right? And isn't this raised to the however often we compound, right? Times the number of years. And this here is your formula for compounding interest. Compound interest formula. All right, so if you like, sure, you can memorize this formula, that's fine. But based on what we're doing, I don't really even think of this whenever I do compound interest. I just think of dividing it into how many pieces and then raising it to that power. All right, so that is all for today, guys. Take care, and I'll see you guys next time.